A manometer attached to a flask contained with ammonia gas has no difference in mercury level initially as shown in the diagram. That is, both these levels are the same. After sparking into the flask, ammonia is partially dissociated as 2NH3 forms N2 plus 3H2. Now, if the difference in the mercury level is 6 centimeters, what is the partial pressure of hydrogen at equilibrium? So, what they are saying is that initially ammonia had a pressure of 76 centimeters of mercury. Why? Because this was the atmospheric pressure and this pressure was acting at this point in the manometer, and the pressure due to ammonia gas was acting on this point. And since in a fluid, the pressure at 2 points at the same level needs to be equal, therefore the pressure at this point will be equal to 76 centimeters. Now, next they say that when there is a dissociation reaction inside, that is, ammonia gets broken down into N2 plus 3H2. What happens is that the level of mercury changes. That is, this level now rises and this difference comes out to be 6 centimeters. Now, the initial pressure of ammonia was 76 and initially there were no N2 and H2. Now, let's say that X amount of ammonia dissociates. Okay. So, now what you would have in this balance equation will be 76 minus 2x, because 2 is the stoichiometric coefficient. And so we would have to work according to the balance equation. So if ammonia is dissociated, 76 minus 2x ammonia remains. For 2 moles dissociation of ammonia, 1 mole of N2 is formed, which implies for 2x moles of dissociation, x moles would be formed and 3x moles of hydrogen would be formed. Correct? Now if we add this entire pressure, because what we worked out here is the pressure in the entire flask. So it would be 76 minus 2x plus 3x and comes out to be 76 plus 2x. So this difference from the initial pressure which we had is 2x. Correct? Now the difference is 2x and we've said that the difference is of a 6 centimeter length. So 6 centimeters is equal to 2x, which would imply that x is equal to 6 divided by 2, that is 3 centimeters. Now x was a parameter which we had used to quantify this equation. 2 times ammonia forms N2 plus 3H2. Now we had to find the partial pressure of H2. What does the partial pressure mean? The partial pressure can be defined in many ways. The partial pressure is defined as the mole fraction of a given component into the total pressure. That is, what amount of the total pressure is being contributed by that particular component. So here the component we are talking about is hydrogen, and we have by default taken the entire pressure to be 76 plus 2x. So what amount of pressure is being contributed by hydrogen? It is 3x, which is equal to the partial pressure of hydrogen. So x came out to be 3 centimeters. So 3x would be equal to 9 centimeters. So this is the partial pressure of hydrogen. Do not get confused by the unit centimeter. It is in centimeters of mercury. Generally, the pressure is in pascals or atm, but it is also calculated in centimeters of mercury. So in this particular question, we have calculated it in terms of mercury units. So the answer comes out to be 9 centimeters of mercury, the A option.